All right, so welcome after the pause. This is the language vision models and bias, the second part where we will start talking about bias first and then move into some of the examples of artworks using these models. Yeah, so let's talk about the bias. We already kind of slightly talked about some of the topics or some of the places where the bias could come from in the previous part. Now let's kind of discuss it. Let's see. So what do we actually mean by bias? In machine learning models, this could mean something different in different cases. So, for example, if we have a model which is kind of trying to identify lesions or something on the skin, if this model is basing its kind of predictions on the wrong parts of the image, it's making some sort of incorrect associations, then we would say that this model is actually biased, because it kind of focused on some sort of other distinctive information in the dataset, so maybe some sort of noise that we by mistake included there, and not the stuff that we as humans would actually want it to like use for the classification. And so this is a little bit iffy in cases where these models get deployed in real-world applications, especially when dealing with human data. And basically there, the bias can be even more serious. And it's even more complicated if we are actually dealing with faces or data sets of kind of containing information about individuals, not just some sort of like samples of something. And also the problem is that if these models are really large, it might be very difficult to actually interpret what we see in these decisions. So there are some visualization techniques, but they may work better in smaller models, or actually they may work for one of these models, but not for this whole chained modular system where we are combining multiple things. Right. What do we actually mean by bias in terms of like, yeah, thinking about it, can we even have a completely unbiased dataset? Could this be the way how to fix it? Which source of data is actually unbiased? So let's say that we, like, if this was collecting about, collecting data from the internet. Let's say that we whitelist some pages that we say, hey, these are trustworthy. Okay, we think that these are good. Well, I mean, this is one of the newspapers that sometimes I read, the New York Times, and actually, is it completely without any bias? Well, probably no. There is some opinion there, some sort of like worldview in the background of this article, of the articles that are on this webpage. So the authors are writing with some intentions in mind, and maybe the writers for these articles are hired by the New York Times for some reasons. And so definitely there is some sort of like bias. There is some sort of opinion. It might not be wrong. It might be some bias that is kind of like maybe, let's say, similar to what my bias would be, but there is definitely some bias. And so I think we got used to kind of this idea that when dealing with human-made content, human-made books, films, anything, it is assumed that the author has some sort of like point of view, and that it's kind of like communicating that point of view for us. And maybe that's kind of like they are trying to push something that we don't agree, they try to convince us. Maybe we get convinced, maybe not. Maybe we see that, hey, okay, this is a bullshit because they are wrong because all of these reasons. But that's something, like that's a behavior that we have when we are dealing with another human agent and interacting with their works. It would be quite dangerous to consider these AI systems that we have here to be sort of more than human, sort of godlike AI, where these systems, because they are AI, they wouldn't have these biases. And so they would kind of have they would just have a pure truthful view of the world. And that's basically, that's not true, that's not possible. At least not with what we are facing with in these examples, because there definitely is some bias. So let's see, what did the authors of these papers actually think about this? So around 2019, where the first, one of the earlier very large language models, the GPT-2, was released. They released a paper first, and they didn't release the model itself because they had concerns about these language models being able to kind of generate vast amounts of articles that are just fake. biased or abusive, and it would be really simple to use these models to just generate fake news, basically. So they didn't release the model. Well, yeah. The problem is that, I mean, then the paper that you released, anyone inside the community of the researchers kind of cannot double check if what you're saying is actually true, because you are just releasing like a statement that, hey, we did really great, but no one can check it. So there are problems with that. And also, some time after this, some other people were able to just replicate whatever the description of the method that was used here was, and just release the new model. So it's sort of like, okay, this was not maybe enough. The authors of Clip, maybe kind of having learned from this whole situation, they have a whole section on bias inside the paper, which is trying to analyze the bias from different kinds of points of view. And they have a sentence there which is saying, Clip and models like it will need to be analyzed in relation to their specific deployments to understand how bias manifests and identify potential interventions. So basically they are saying, hey, we know we have detected some bias in these, we know it's not really all right. Before this gets deployed into real world, we need to somehow check it. We need to figure out some ways how to like get rid of the bias. But at the same time, it's not super strong statement. They still are releasing the paper. They are still really like positive about the Clip model in all of the blog posts and everything. The problem is that if these models get deployed into real world, and if there was some bias in these models, then it's not easy to see how this bias would get propagated to kind of some down in the line tasks that these models would do. So, for example, we could use these models for some sort of classification, and the later decisions made based on these models might be somehow influenced by the bias inside these models. And regardless of the warnings of the authors, these models are already being used in some projects. So some image search websites, or some so-called zero-shot applications for classification, object detection, object tracking, and more. Right. Can the bias be somehow discovered? Yes. So using some sort of downstream tasks, so that's exactly what I was kind of talking about. We have these models and we use them in some way. And so these downstream tasks are the kind of the application that we apply these models for, and the kind of the way how they actually work in the end. And we can check if the results of these, or like the predictions of using these models, if they are influenced or if they are not influenced by some factors. And then we can kind of double check if these factors are something that we care about or not. And so we can kind of teasing out this sort of bias by adding some adjective and seeing how this model reacts to it. So this is, again, still from the original paper. They are basically trying to classify faces from a fair face dataset. So that should be a dataset which has a relatively equal amount of faces from different kind of categories. So it's an attempt to kind of have a more balanced dataset in regards of these categories, and then to see if these subsets that are made by this dataset, if they kind of are firing or not when they are trying it with either some crime-related categories, so thief, criminal, or suspicious person, versus if they are trying to, well, that's one kind of test, or another kind of test if it's if they are trying to use these like other animal comparisons. Right, and so the idea is that this is trying to tease out if these models have some sort of like racism inside of this. And so it turns out that when adding these probes of adding animal words into the prompts that were used, the faces from the black category were kind of like had the highest misclassification rate. In some other tests, the male samples were mostly were more often misclassified into the crime categories, and some other kind of, like, because there are a bunch of categories that this dataset has, people aged 0 to 20 were more likely to fall under crime as well. So it turns out that even in the original analysis, in the original paper, they already know that this model is kind of like, in some way, it's kind of racist, it's kind of sexist, and it's also kind of like ageist. And so there are just problems. And so all of these analyses are ways how, like, why they actually released that statement, or like added the statement that, okay, maybe these models shouldn't be really used and deployed into real world just yet, because we need to figure out how to kind of get rid of this bias. Right, so these were kind of some scientific ways how to analyze bias and how to kind of try to measure it. Let's talk about some kind of more visual possibilities to show if there is a bias or not in the model. So there is an art project by Nathaniel Stern, and it's called Are Computers Racist? And the project kind of description is this one: what will a computer conjure if you ask it to produce a photograph of a thug? How does AI imagine an ideal man or woman? What about a rioter? What color is each of their skins and hair? What about their surroundings? What are they wearing in these generated images? What about the body language? And so there is more. I think it's a really interesting project, so check it out. The kind of prompts that he was testing are these exact ones. So basically a portrait of a thug in the style of a photograph with a style of photo. So it's kind of just like adding these in order so that the clip model can generate it. Well, so that the VQ-GAN plus clip model can generate it. And so this is something that is the result of a portrait of a thug. This is something which is being generated as a portrait of an ideal woman. So basically, not only just skin, but also kind of maybe some concepts of like what is beauty, what is not, what is the hair color, blonde, and all of this kind of comes from the fact that it was trained on the internet. Right, and so this is a relatively old project, and you may think, okay, maybe there is chance to actually fix these models. And so I was playing around with this model, the Disco Diffusion 4.1, which is maybe like a month old version, but it's still using the same underlying models probably. Maybe there are slightly different ones, but for example, the clip is probably the same one. And the content and style prompts for this one image was portrait of a thug and a photograph. I was basically inspired by this project and just did the same thing for this class. And it's basically a very simple just start of this. So I think over time it would get much higher quality and higher detailed image generation. But the problem is that this basically has the same underlying bias as the previous one. So because this model was basically trained on some dataset that has been scraped at one moment, and the fact is that they don't retrain this model, they don't update it, so it doesn't really adapt to, even if the societal kind of ideology and ideas would change, it doesn't adapt to that. It doesn't get fixed by changes to the internet, because it's just a single kind of image of the whole scraped internet at that point. So yeah, this is generated like yesterday or something, so it's kind of like still, basically, it's still there, if you are wondering. Yeah, so what's the problem with the datasets? Well, the datasets are simply too large to be properly audited and curated. It's 500 millions of pairs. It's not possible to kind of audit it. Also, these datasets have not been released publicly, and the description of how this data was collected is quite wishy-washy in the paper. So it's not really saying which pages were used, were scraped from, what kind of algorithm was used to kind of branch from one page into another one. This is not kind of anywhere clear. They are stating that some filters were used to kind of like protect the data that is being downloaded against some not safe for work images. However, that didn't fully work. How do we know? Because we don't actually have access to the dataset or the list of web pages that this scraped it from. But there is a simple visualization technique, which is again based on something like Deep Dream, where from the whole network, you select one neuron, and then you get the images, get the images, get whatever the input noise to look like what this neuron would be firing on. And there is some people have found this one particular neuron, which can be just described by this image. And this is the only safe for work image on this webpage. So just check it out for yourself. The link is this one, or you can find it in the PDF. And it's of course firing on other images like this. And the funny thing, though, this is actually quite funny image, right? But the thing is that because these models have been trained on pairs of data, then even text description and the image actually does fire together. So this is, even though there is text in this image, it's still firing for the same concept behind this. There is a kind of, obvious kind of comments on the internet. This is somewhere around the post with this being released. Scrapes the internet, finds porn, surprised Pikachu. Of course, there is some material like that on the internet. And for example, I'm not saying that these models should be prevented from accessing any sexual content or anything like that. The problem is that quite often on the websites that this stuff is on, the language is kind of particular and is quite misogynistic, and it's kind of there's loads of problems from just stemming from that. So even if we are kind of acceptable to whatever type of whatever, it would still be problematic because the associations that are in these websites between images and text descriptions or titles for the videos, whatever, right? This would get propagated to other tasks as well. Actually, how? Well, there is an example of this. So this is crimes of the vision datasets. This is coming from from this paper, which is really good actually to look at if you care about this sort of stuff. I will add more links at the end of this slide as well. But yeah, so this is a photo of the astronaut Eileen Collins, and it's basically one of the demo photos in the SK image library in Python. So whenever you want to load an image and then play around with it, use some filters or whatever just to test your coding and stuff, you can download this. So this is, of course, this is a data samples which is just present on the internet. So it should be easy for this model that has been trained on the internet to be able to analyze it well. The problem is that with this clip model, anyone can bring any type of prompt with any type of image. And so how you write these types of prompts is kind of, it's up to you. So you could ask it wrong types of questions and it would still fire some sort of similarity. And sometimes it actually might be problematic because it might have higher similarity for something that you actually don't want it to fire on. So A, this is the correct statement. This is a portrait of an astronaut with an American flag. Okay, similarity 0.27. Just as a, by the way, higher similarity means more of a match. So match between this sentence and this image is 0.27. There is another description which has been tested by this paper. This is a photograph of a smiling housewife in an orange jumpsuit with the American flag. And the similarity between these two is 0.30. So it's higher similarity between these two image to text pairs than these two. And basically that's propagated stereotype that was probably captured somewhere on the internet. And so they also talk about this in the paper, that the main point is not to actually say, create a provocative statement, hey, this all is wrong, just don't use this at all. The problem is that it was quite easy for them to find these misassociations baked into these models, and this is just basically a problem for any kind of usage for later tasks. If you want to test this, there is a collab which is basically still running this task, and this paper is really good if you want to read about this topic. The same kind of paper is showing another example. This is the portrait of a former president of the United States, 0.28, and Obama. And then this is the portrait of the first ever illegal president of the USA, born in Kenya, 0.30. So this links to a conspiracy theory which was floating around the internet, at some point, and the problem is that basically this model which has been trained on the data from the internet captures all of these sometimes problematic materials, and it also captures the stuff that has been there in the fake news that this was scraping on as well, clearly. So yeah, this is a problem, of course. Right, downstream tasks. So we kind of like talked about this a little bit before as well, that the problem is when we take this model and then use it for something that it was not trained on. And you would think that this is kind of obvious, but this is the whole promise of this model being zero-shot. The promise is that it has out-of-the-box functionality, so you can just load it from OpenAI and start using it for anything. On the website of the OpenAI, how this is being described is that CLIP is a flexible and general model. Because to validate, we have measured it on zero-shot performance on 30 different data sets. We are outperforming all other possible methods. It's better than like ImageNet models, noisy student efficient net, etc., in a lot of these tasks. So even though they have a section on bias, they are still talking about this model as like, okay, this is a very flexible model and it's very general, you can use it for anything. And there is this promise of out-of-the-box applicability functionality, which is a bit problematic. Another point is the sort of accessibility of this model. And that's kind of twofold, I think, because at one point, this model has been released last year, and there have been so many notebooks using this model that it's actually really easy to use, very accessible to use, because you just open up the collab of this notebook and use it for inference on the internet for free. There might be some limitations on how well can you get with whatever, like the free instances, but still, it's basically for free and a lot of people are using it. So it's very accessible on one hand. On the other hand, though, it's not accessible at all in terms of it being almost impossible to train it on your own data. So the CLIP model is just too large, so you cannot even collect your own data of that size, and you cannot probably train it on your own. You could maybe fine-tune it, but that's maybe like that's still not getting rid of the possible bias. It's just kind of like hiding it behind the fine-tuned data. This still may be remaining there. and famously, kind of the costs for the large-scale language models are really high. So for these companies, the OpenAI, the task of training these models, it's like very large kind of like cost involved in this, in developing this. So of course they are kind of like, they want to use it actually. They don't want to just say, hey, okay, we did this, it's biased, let's not use it because it's problematic. The motivation there is to like somehow do something with these costs, with the involved financial and also time-wise, all of these possible costs. There is, of course, the question of like, we maybe don't want to retrain it every time, this whole big model, because maybe it's actually like cheaper in terms of our costs when wanting to use a new task to reuse something like this, the out-of-the-box promise, right? If you could just use this for anything, then you don't need to train this really large and really expensive to train model. It would actually be better for the environment as well, because you don't have to retrain these large models all the time at every moment. The problem is that like you actually maybe shouldn't really use it for like in other real world tasks, because there are probably some biases in there. So finally, I think I would also not want this message to be kind of like a scare, like, hey, let's not just use these. I think that this field is something that should be studied, talked about, analyzed from perspectives of multiple disciplines. So not just CS kind of research or research oriented, but also actually artistic way of interacting with these models and trying to see this stuff. If you care about this, check the related readings. Some of them are quite readable actually. And then, I mean, there is some chance in this whole field because there is more and more focus in this part of the research. So even from inside the research community, this is kind of more known now. And so people are trying to figure out ways how to fix it, how to detect it, how to kind of yeah, how to approach this. Because at the same time, actually, it is really cool, the whole promise of these models, and it's really useful in research and also actually for art and when making some artistic projects. I am not saying that we should not use these. I am saying that we should kind of know about this part as well, honestly. Okay, so finally we are making it to the art examples of this method of the text to image generation. So there is this one particular notebook called Diffusion. I'll just leave the animation play a bit. And so it's it's one of the versions which is kind of like has been copied from the previous notebooks and always adapted. It's a 4th version, and there is also like a few days ago released 5th version. So there are some small tweaks how to like improve the fidelity of these images, or how to kind of add more functions. So sort of like there was some mentions of like video inputs as possible seed for the images, or image input, or better way how to use these. And you could see in some of these as well that you can see the progress of like it being trained from relatively bad images to kind of adding more and more details. So this sort of stuff. So I think this is a really good one to start with. It's one of the most recent ones, and it's actually super cool, these images. I love these like steampunky images. Right, another notebook, another kind of famous one is this Aphantasia, and yeah, I mean, sorry for mispronouncing that. This concept means the inability to visualize mental images, the deprivation of visual dreams. So the idea that like some people basically, if you tell them, hey, imagine a situation, and they would visualize it in their brain, they cannot. And so this is a sort of like jokey way how to talk about this model, because this model is something that is basically trying to imagine these dreamy like images that are supposed to correspond to some text prompt, to some idea that we placed it. And so it's not just the text prompt, but in theory it's this whole kind of like the whole how this text prompt relates to other things. So visualization of that whole thing, because it's somehow going through the clip model, all of that. The difference with this model, or this approach of this repository and these notebooks, is that it works directly on the images. So there is no generative model there. It is directly optimizing the image, and so it actually looks a bit more like Deep Dream, a little bit, because it's just optimizing the pixels of that. And there are some tricks in that as well. So this it allows for text to video synthesis. So this basically example, and it is the Illustrip, the technique, and it's here in this repository. And so it allows you to kind of like give it multiple different text prompts, and it would basically go from one to another to another to another in this video like setting. So it has been the proposal is to use this for like lyrics for songs, where you can just like start with different sentences of the song, and it will kind of go through the dreamscape of this, what these descriptions evoke. So this is actually really cool. I mean, at this moment, I would like to kind of jump away a little bit into kind of the field for this film that I saw recently. It's called "Is the Man Who Is Tall Happy?" And it's an interview with Noam Chomsky, who is, by the way, also a linguist who is behind these kind of, at the beginning, we were talking about these like older methods of modeling language, writing down these trees. Noam Chomsky is one of the people defining the way how you like would create these syntax trees for sentences. And so it's kind of related to our topic in that way as well. But also, and I will quote from this film, the author of this, Michel Gondry, is saying, "Film and video are both by their nature manipulative. The editor-director proposes an assemblage of carefully selected segments and basically makes a point by constructing the whole reality of the film." And so in a film, in a regular acted films, there will be a situation that will convince the character to do something or to think something. And for us humans, it's really easy to forget that all of this is a fabrication of some director, of some team of people. So even the fact that this situation has occurred is a manipulation, sort of. And the fact that the people inside that situation will change their mind in some way, that also has been fabricated. And the effect on us is that, okay, we maybe think about it in a way that, oh, I see in this situation, okay, this is the thing that, this is the way how to behave for me as well. And yeah, that's a bit problematic. And so the author of this film, Michel Gondry, is saying basically that by animating, but by kind of forcefully disassociating the footage that you would have with a camera, making it look abstracted, making it looked like at every slide you know that this is not the reality, right? These are just images that he was drawing. This is to let the viewers, us watching this movie, to never forget this, that it's basically just a point of view of this guy making a recording of the other guy. It's some ideas that are coming from the mind of one person, and then these ideas get bounced by the idea of this other person who is making these illustrations, but it's actually not the truth, not the absolute truth of the universe. It's just some opinions. I mean, I quite like that concept on its own as well. So if messages or even propaganda can be delivered through film, the audience is constantly reminded that they are not watching reality, because it's always being abstracted through these like animated drawings. So that's interesting. How does this link to like the stuff that we were talking about before? Well, in a way that these are some of the screenshots from the film, and so it's quite like, it's almost like philosophical discussion with between Noam Chomsky and the director, and one of them is describing some ideas, and he is almost like visualizing whatever this like discussion that they are talking about now, what is it evoking in his own mind. And so he's talking about the way how we see the world, and at the same time on the screen of this film we see the drawings of like a person being attacked by the world and making a new point of that world inside their head and stuff. And so it's a bit similar like when you are listening to a lecture and if you start absent-mindedly drawing on the side of your notes some drawings, and maybe those will actually allow you to jump, make some like associations with other stuff that you were thinking about. So it's really cool by, yeah, this combining a quite visual world with like quite conceptual world of the scientist and the philosopher and the sort of artist and the visual mind, and going back and forth and stuff. And so, I mean, it's a really nice movie. Also, this is the syntax tree that the language can be represented as. The man who is tall is happy. There are some rules about like how to make this statement, how to make that into a question. Well, you will take the is and swap it to the front. But which is do you select? Is it this is or is it this is? And the idea is that you would select the is, which is like, which has the lowest distance from, well, smallest distance from the beginning of the tree. So you wouldn't swap this one. Is the man who tall is happy, because that makes no sense, but is the man who is tall happy? That one. And so that's one example of a rule that we have in the natural language, sort of. And as we talked about it in the beginning, this might be quite hard to actually describe with these rigid rules. But yeah. So the whole idea, how does this link to like this text-to-image synthesis, right? Is that we could use these models to kind of like generate these visual scapes of content for whatever we are writing about, thinking about, speaking about, recording a lecture about. This could be the visualizations that are being fed there at the same time. So that's kind of the conceptual idea behind this model as well, a little bit actually. All right, jumping to another cool example. Is that some of these notebooks are using the same kind of technique, but they are quite nicely stylized. So there is this, there are like two kind of similar projects. One of them is called PixRay, one of them is called Text to PixArt. They are inspired by DripNet, the author of this. And so these look like this. So it's again like from text prompt, you would generate a pixel art image and then also animate it. Similarly like in the previous cases, but just the stylization actually looks super nice in these. Okay. So this is kind of a little bit like talking about, well, we are getting how to actually use these models. So you would start with one of these notebooks, and then you would ask it for a prompt. And if it turns out that just asking it for a prompt of a, like, let's say, a mushroom, some of these images would be quite messy. And so the way how you kind of can interact with this model is to add some keywords. And for example, because this model has been trained from the whole internet, it has a bunch of images which have been scraped from these like places where people publish their photos or their drawings or their illustrations or renders of 3D models. So if we would add Flickr, mushroom Flickr, it would generate more photorealistic like images probably. If you would add ArtStation HD, it would probably generate more like paintings like images, and you can kind of go on and on with this. So you are almost adding a style like HDR to the image being generated, or ultra detailed, and all sorts of these tricks. There is a whole list of these on these websites. You can also like almost prime these prompts with some art movements. So you can say in the style of Impressionism, and it will start making these images like of a mushroom in the style of Impressionism. Furthermore, you can actually add special authors. So this is an example by Rivers Have Wings, who is actually one of the authors of the original notebooks, interacting with this whole field until now. And this is also quite recent, I think. Aeneas Icarus, the sand creature by Karel Thor, is the sentence that has been used to generate this image. So the stuff in the above here, this is the generated one. And this was the sentence to generate it. And Karel Thor, by the way, is a... there is some article describing it as a surreal sci-fi horror painter, and so he makes images like this. And just the point is, in this case, is that like you can kind of like prime these generated images by author names and by style names, or by the almost the names of where this would be displayed, and you can kind of like try to reverse engineer how this image would be described on the internet. Which is like, because that's the data that this model was trained on. So it's kind of like quite interesting how to like compose these. And by using these correctly, you actually can achieve these super high res and super high quality images. Whereas if you would just say, hey, I want the sun creature, it would probably fail because it doesn't know what you mean, sort of. Right. Okay, we are kind of getting to some of the more other uses of these models. So this is no longer talking about the text to image generation. It's just one example of using the clip model. And so there is this article of associated with gunscapes. So creating a regular gun, which is generating impressionistic images or paintings. And so the concept there was that you can collect data that corresponds to Impressionist paintings, but it's quite often quite messy. You will have a lot of images that actually are not really Impressionist, and maybe they were just misclassified in some dataset. And so using this clip, you can like rank all of them with Impressionist painting as a prompt and the image, and then look at the distances between all of the images in your dataset, and look at the sort of top hitters in this list, and then the bottom hitters. And so you and then, like, thankfully, if it's small enough dataset, you can check it manually as well, which is the important bit, I guess, I think, actually. And so you can see that, okay, it's actually working for the top hitters, and it's also actually working for the bottom results in this list. It is correctly discovering images which are probably not impressionistic. Maybe they were like, maybe this is conceptually similar. Maybe it's a photo of a thing that was actually also then painted as a impressionist painting. I think this one, right? Looks like it. Or some of them are like just kind of like slightly different styles, and you might not want them, so that the model that you are training on these doesn't get confused too much. So this is a usage of this clip model for pre-filtering of your dataset. And then finally, this is kind of like a more conceptual point, is that, all right, so these generative models, they are biased. What can we do with it? Well, I mean, we can just sort of ignore it and just like play around with it in some way where we know it will be okay. Or we can actually use it as a sort of mirror to society. So these are the examples of the, if you just give it a prompt and then see that it's problematic, this is what does it say? it makes a statement about the state of the internet, let's say, because it makes a statement about the data that this model was trained on. So similarly, there was a project that actually we were working on some time ago, where there is a link between like the fake news that are being spread around the internet and the sort of like the general subconsciousness of the people on the internet, their fears, their kind of hidden desires, and by generating new images or new data based on this, you are kind of maybe sometimes slightly uncovering these like sometimes even problematic desires or problematic fears or problematic opinions, or the fact that there is a lot of misinformation in that particular data, let's say. So I think that's also something that we as like artists can actually work with too. All right, so we are basically at the end of this class. There are some few more extras that I would like to show or like link you guys to. So as a summary of this whole lecture, we described what the model clip is, how it works to measure distance between images and text, how to take that model and then use it to actually generate new images. So the whole backpropagation of the information that will satisfy this model in a way to change it, iteratively changing this model in that direction, basically, in the direction of the description, in the direction of the like banal like photo, if that's the prompt. We then talked about the bias in these models and the data sets and what does it mean and what can we do with it. And finally, we discussed some of the artworks, visualizing the bias, or just some of the kind of some really amazing imagery that can be produced with these models, and how to kind of prime it with this keyword prompts. So to show you some further readings, I think it's quite useful to read this clip paper because, I mean, it is just 1 year old and it is really already being cited quite a lot. So it is a big deal inside the research community. But at the same time, you also get to kind of know what did they try to fix the problems with bias, which kind of like bias they were able to detect already at the release of this model, or like at the sort of iteration of like thinking about this. That's part of this article now. And what they were able to see and what they were not able to see. So that's kind of useful to look at. If you are just kind of interested more in general in the area of the text-to-image art scene, let's say, then this article is really cool as well. It has some nice visualization and it has just loads of examples of really nice artworks and a little bit of the history also of this art scene. If you care more about the bias chapter of this whole lecture, then I would really recommend first this multimodal datasets paper. So it's the one where we saw the analysis of these images. Then there is maybe slightly more readable article on VirtualBeat. There is a slightly more academic, on the other hand, opinion piece by Yarin Gal, who is a researcher at Oxford, who is working with like uncertainty of models and how that helps or hinders applicability of the models in some real-world scenarios. For example, in autonomous driving example, and this is an opinion piece that having this model, which is trained on data which has not been really curated, would be really like harmful to actually use in some real-world cases. So this is one article like that, or just this whole project about bias in classification models in general, so the gender shades project. Okay, so this is it for today. Let's talk later in the practical session where we will try to use one of these notebooks to generate some images on our own and play around with this model and test how it actually works.